Hi everyone, hi teacher, and hi my fellow friends. We are Chad Shen, my teammate, and me, Chen Ken, from IS Year 1 Sem 3 Group 2. In this assignment, we are hired by Sri Muda Gold Sendihan Berhad, a new food processing manufacturing plant in Johor, Malaysia, to set up local area networks for the company. The table below shows the required hosts for each building, and we have separate with color for each building. For the building A, we use red, and for the building B, we use yellow, and C, we use blue, and building D, we use green. And then, as you can see, there is growth needed of subnet address. The growth needed is 20%, and we already calculated for them. So you can take a look. And then the next is our addressing design. We decided to use VRSM table for this assignment because VRSM allows subnets of various sizes to be used in order to maximize the use of IP addresses. In flexibility, it also allows network design to be more flexible by allowing different subnet sizes on the basis of specific requirements. Then VRSM enables the ability to create subnets of different sizes as needed, with a view to improving network scalability. In complexity, VRSM requires more planning and management due to varying subnet sizes and custom configuration. We consider assigning an independent subnet to each department in this assignment. Each department required to have minimum 3 end devices to stimulate the host on the network. For the cable, we use copper straight cable to connect between the end device and the switch. After that, we use copper straight through cable to connect between the router and the switch by using Gigabyte Ethernet interface to form local area network. And the color I have stated just now, we use red for building A, yellow for building B, blue for building C, and green for building D. And the class we use in this assignment is class B because in the future we might add more end devices. So we think it is good for our design. And also class C is affordable for this assignment, but we didn't use it. Yeah. Okay, and then the next is our VRSM table. You can take a look, and we already use color to separate it, and there is host required and the host bit and prefix, subnet mask, subnet address, first usable host, last usable host, and also subnet broadcast address. Okay, and then the next thing is our addressing table. As you can see, the first one is the router, like building A, building AGD, and building B, building C, building D. This is all the router name. And then so on. The switch name, we decide to use the department name to name it, like logistic is the switch of logistic department, and so on. Yeah. And the end devices, we also decide to use their department to design it. Okay, you can take a look. And the next thing is our network topology is using star topology because it is flexible, and the blue color is for building A, green color is for building B, yellow or gold color is for building C, and pink purple is for building D. Okay. And we also have we not only use PCs at the end as the end device, we got use server and printer also and laptop also. Yeah. And my part is finished. I will pass to Chet Dongsheng, my teammate. Thank
Okay,
you.
next. Thank you, Chicken. Next, we'll be going to network configuration. So for router password, the question requires us to set up the password for both router and switches. So there's 3 passwords. The first is the password for Cisco for the entering, for the login. And then the second one is the line VTY 0 to 15, and then, which also is recognized by the password Cisco 2024. And then lastly, there's the third password, which is secret class, which is class 2024 for enable. And then this is the same for both router and switches. Have to allocate for every single router and switches. So the router is differentiated by the building. So every single router, as stated here, is configured with the passwords. Same goes for the switches. And now we'll be going to the IP addressing and the subnet mask for all routers and switches. So for IP addressing and subnet mask, the command is starting with enable, then you enter the password as configured just now. And then also then you go into config T, and then then you put in your interface name and then your IP address with your subnet mask. And an example of this is, let's look at this block A, building A, ground floor. For example, we go to interface name, interface G gigabit 0.0, and then IP address is this IP address. So as you can see, now it's ground floor. This is the interface G/0/0, G0/0, and this is the IP address, and then with the subnet mask according to this building. Yeah. Okay, the next same goes for the other address G0/1, 1.1, and then according to the subnet address. Okay, then going to the switches, also same thing. We use interface, and then for interface here we use VLAN, and then IP address with IP address, and then subnet mask, same thing. So an example of this is here, IT department VLAN for the interface, and then IP address with the subnet mask, and no shut, and then we also set up the IP default gateway to allow the packet from device pass to switch and then pass through the router. And yeah, the default gateway is to set up for the switch to pass to the router to pass to another department, to another building. So for all the end devices, as you can see, the configuration for IP address for end devices and subnet address is very easy. You just click on any end device. Example, you go out to configure for PC3 marketing department. Then I go desktop, I click IP configuration, and here I can just put 172.168.1.7, which is the IP address, and then with the subnet mask as calculated according to the VRSM table and IP addressing table. Then we put in the default gateway with the router address, like here. So like this. And then that's it for end devices, because it's the same for every single device. The configuration according to its own IP address is subnet mask, and then default gateway is the router, the cable connecting to the router. Okay, and next, so now we'll be going to pinging connectivity. So pinging connectivity is to show that one packet, the information can be passed to another router, to another department or another building, and then another department in another building. So an example I can give is, let's say we go to logistics PC3, and then desktop we go into pinging command prompt. Okay, then let's try with the same department first. Ping 172.16.2.5. And as you can see, all the 4 packets it's sent back, it received, sent and received. Okay, so within our own department, there's no problem. And now let's try with a packet, n devices that's further away. Let's go into building D, which go through 2 routers, building A, GD, and then building A. Okay, now we will go through this department, manufacturing department, PC3, ping 172.16.0.7. And we'll have to wait a bit. As you can see, sometimes it requires timeout. So you will need to do it again because the connectivity will be established by then. And as you can see now, the pinging is successful. So all the pinging is actually successful, as you can see here. It's for different buildings. We have pinged 15 departments, all 15 departments. So for digital resource use, we have used Cisco Packet Tracer to build our own topology and to replicate the modern computer networks. So we use this software to simulate the configuration of Cisco routers and also the switching using the simulated CLI, the command line interface, to know that these end devices can ping to another end devices through all these routers and cables. And then we will be also using YouTube to upload our assignment presentation and also use YouTube to find our resources to learn more about our Cisco packet. The same goes for Facebook and Instagram for the social media. And we'll be using Zoom for our assignment presentation, for the recording, and to have our meetings. And then here is our YouTube link. And also here is our reference. And that's it for our presentation. Thank you, everyone.
Thank you.